right, now the moment that many have been waiting for. I would like to invite a few sharks up. Dan Gold is our moderator. And I would like to invite Gene Hausheer, a.k.a. Lori Greiner, coming to the stage. And I'd like to invite Juan Batlle, a.k.a. Mark Cuban, coming to the stage. And I'd like to invite, let's see, who else should we invite? Vipin Doss, a.k.a. Mr. Wonderful.
Good morning. This is the inaugural Innovation Shark Tank, and it's really an exciting idea, especially after what we've just heard. It's my belief that God is using missions, and it's changing. We were doing missions the way we were 100 years ago, and now we're looking at things differently and trying to innovate and use some of the advanced technologies. And so one of the things that we're hoping out of this session is that ideas that you have, as we bring them into our community and we're able to collaborate on these ideas, we might make a difference in the world. Now in the Shark Tank that they have on TV, people will come in and make a presentation in hopes of getting money to start a business and make more money. Our hope in doing this is that we're going to improve the way that we do missions in one of two ways, either in the delivery of medical care to the poor, but perhaps in my heart, at least more importantly, is in the delivery of the gospel in areas of the world that we just can't get into, and in creative ways, bringing the light of Christ to the world. And so there may be some ideas that are out there, and this morning we actually have 10 ideas, 10 presenters. Only 6 of them will be done here live in the meeting. So there are 4 other video presentations that you can get either on the COS website, or we will have a link to the app, and we want you to go to that link sometime today and look at those so that you can judge those, and you will be the voters, the judges. There will be an opportunity. If you look on the app on your cell phones and you press on the little link that says Innovation Shark Tank on Friday morning, if you click on that, at the top of that page you'll see a little form that'll say 3 polls, and if you click and open those polls, you'll be able to vote for each of these presentations. And the voting will conclude at 6 o'clock this evening, and then we have some prizes for those that are winners in each of the different categories. Is that all clear? Great. Without any further ado, our first innovator, our first person to enter the Shark Tank. We've got a little video presentation to show you, and then we'll bring in our first presentation.
Welcome to the COS Shark Tank, a new twist on your favorite show. Today, 4 successful ophthalmologists with a passion for missions will be your judges. They will comment on the innovations presented today. Let's meet our judges. Juan Batlle is the director of the Elias Santana Residency in the Santo Domingo. He is fellowship trained in retina, peds, and neuro-ophthalmology. He founded Central Laser, where he is involved in cutting-edge research for new treatments. As opposed to Mark Cuban, Juan does not own his own private jet, nor the Dallas Mavericks. However, he is actually from the Caribbean, which is more than Cuban can claim. Anthony Vipin Doss is a proven innovator, a key member of the LV Prasad Innovation Center. He was the chief architect of iSmart EMR, helped invent the folding phoropter, haptic shoes that guide the blind, and more. As a TEDx fellow, he helps organize TEDx events in India. As opposed to Mr. Wonderful, he is polite, not condescending, and very encouraging to everyone he works with. We prefer to call him Mr. Incredible. Gene Hausheer, a clinical professor at Dean McGee Eye Institute. She is a proven residency program director and is the newly elected president of the Oklahoma State Medical Association. She's active in helping around the world. As opposed to Lori Greiner, she does not market on QVC or have connections to get you into Walgreens or Lowe's. She's more likely to get you hooked on to the Mercy Ship. Dan Gold has been in solo practice for 25 years in southeastern Texas. He is a globe-trotting cataract surgeon who doubles as a pastor at his local church. Among many countries, he has operated in northern Iraq and Syria. He loves the Middle East and even lives in a town called Palestine. Although his name may imply that he has the Midas touch, he is not a multi-billionaire and does not wish to become one. It's said he wishes to store his treasures in heaven, heaven, heaven.
Now entering the Shark Tank is Dr. Abe White from Kansas City. He has a better way to give anesthesia for M6.
Good morning, Sharks. I'm Dr. Abe White. If we could pull up my PowerPoint, please. So, Sharks, it's summertime, the time when all the movie theaters and movie studios release their sequels. You know, it's basically old ideas that once upon a time made a lot of money, and hopefully they'll make a lot of money again this summer. And so my idea is not so much a truly revolutionary idea, but rather a reapplication of an old idea. All right, so my thought was using subtenon anesthesia for M6. So, you know, when you think about all the bad things that can go wrong on a mission field, one of the things that you would consider would be, well, what happens if you get a retrobulbar hemorrhage, or, you know, unfortunately, if you were to get actually a block into the nerve that would actually go back into the brain and could cause apnea. Now you've got to bag mask this person for the next 12 hours until their diaphragm wakes up again, basically. And that's a pretty big risk, especially if you're, you know, in an area that doesn't have a whole lot of resources, and you may not even have an anesthesiologist to help you out. So I'm thinking, well, you know, there's got to be a better way to do this. And one of my colleagues at the University of Kansas, who's a glaucoma specialist, actually uses subtenons anesthesia for all of her procedures, including tubes and trabs. And so I thought to myself, well, if this works for a tube or a trab, why wouldn't it work for M6? So the concept for subtenons anesthesia was first described by Stevens and BJO in 1992, so it's definitely not a new idea. And it's commonly used for phacoemulsification. It can also be used for glaucoma and retinal procedures. The technique, essentially what you'll do is you place a sponge or a wax cell that's soaked in whatever your local anesthetic of choice is in the infranasal quadrant for about 10 to 20 seconds. Then you make a small conjunctival cut down in the infranasal quadrant. You dissect posteriorly along the sclera back to the equator with some Westcott scissors, and then you just place a blunt cannula in that space that you've created and slowly inject about 2 to 3 milliliters of 1% lidocaine, and 10 seconds later you're ready to operate. So, you know, I asked the question of some of my friends and colleagues who do M6. It's like, well, why don't we use subtenons instead of doing peribulbars or retrobulbars? And the response that I generally got was, I've never tried that before. Let me know how it works out. So I did. And what I found is that you get really great anesthesia. And this is a technique that you can do on the field, so it doesn't require you to do anything in a separate pre-op area. It doesn't require any separate person. The surgeon can do the block right on the field, so it doesn't really slow you down in terms of your progression, your setup of your procedure. You've got a lower risk of hemorrhage, you've got a very low risk of optic nerve damage, and an extremely low risk of systemic anesthesia complications because you're using a smaller amount and you're putting it right where it needs to be. This significantly reduces discomfort for patients from the operating microscope light, and so I found that a lot of the patients that move around on me during topical anesthesia, the problem really isn't that they're having pain, it's that the light's bothering them. And so this helps a lot with that. In addition, because you can use plain lidocaine, these patients have a quicker return of vision, and I don't even generally patch these patients. So it's a technique that if you have somebody that you need to do a block who's, say, monocular, this is a great technique for that because when the block wears off in 4 hours, their vision's back to normal. This can also be done with very minimal sedation compared to a retrobulbar or peribulbar block. You don't have to snow patients with propofol for this. In fact, my typical protocol here in the States is I just give the patient a 0.5 milligram of Versed as I'm putting on the drapes, and then they're ready to go. Very minimal equipment requirements for this, so it's very applicable to a mission field. You can get reusable blunt cannulas. My personal preference, though, I just use a 23 gauge IV cannula. Stick it on the end of the syringe. It works fantastic. There are a few limitations to this, as there are with any technique. It is a little bit difficult to do in eyes that have had prior surgery or trauma, particularly in the inferior nasal quadrant, so just keep that in mind. You also don't get as consistent an akinesia as you would with the retrobulbar block, which isn't necessarily a bad thing. The one thing that can be a little bit of an issue is that it will sometimes miss that superior division of cranial nerve 3, so you can sometimes get a little bit of a pseudo-Bell's, which I guess would probably be a little annoying if you're used to doing M6 superiorly, but real men do it temporally anyway. And it also, this may not be an ideal technique if you're combining this with MIGS. I haven't tried that yet, but I'll let you know how it works out. Another small issue is you can get some subconjunctival hemorrhage or chemosis. This happens particularly if you aren't able to get the cannula posteriorly enough. And this can make glaucoma procedures a little bit more challenging, although my colleague, as I mentioned, in Kansas City uses these for all of her glaucoma procedures, and she does fine with it. And that's all I have. I'd appreciate your vote.
So, is this a new idea? Because I understand people have been doing topical and subconjunctival injection all along. How's it different?
So the thing that makes this different is that everybody that I know has always used either peribulbar or retrobulbar blocks for M6. And so this is just basically reapplying the old technique of the subtenon anesthesia to M6. So it's just an adjunct to M6. It's not truly a new idea, but just a repackaging of an old idea, so to speak.
So Abe, with this proposal today, you get good anesthesia with subtenons, but akinesia is not reliably there.
Right.
And so if you're working in a situation where language is a barrier between the surgeon and the patient, and they're looking all over the place, don't you agree that that could be a little bit challenging?
Could be a potential issue.
Yes. And a lot of us do it superiorly.
Including me. Right. So thank you. I mean, as I mentioned, it's always good to look back in the past to see what is useful, as opposed to the apprehension of looking at a needle that's approaching your eye for a patient who might not even be able to communicate to you. I think there's something there. But you didn't mention anything about any scientific literature that's been there in the past to actually show, just as what was mentioned for akinesia and anesthesia. That would have been helpful. But in my opinion, I think if you know it's working and it's safer, I think it is something, if it works for you. I've had patients get up and walk away from the table as well. But I think it is something that I think you should pursue and see where it goes. Yeah.
Yeah, that's a great point. Actually, on our mission, it's funny that you'd mentioned that because we actually have had a few patients who are coming in getting prepared for surgery, and when they see somebody else getting the retrobulbar block, they try to like crawl out the window to escape.
Yeah. And I'll tell you. So I was training in my post-graduation, and there was this old gentleman who was there. And as new postgraduates, your first task is to give blocks for lists that keep going on. And then he saw me approach him with the needle, and then he said, I want to go home. I said, but you came here to get vision. Why did you come to the hospital? He said, I have a fever, that's why I came to the hospital. He was trying to find reasons to just go away, which was cute. Of course, I spoke to him, gave him the block, and he regained his vision. But that's, I think, one of the significant things that we should not overlook in our patients here.
Abe, thank you. I actually had an intrathecal block in Africa fortunately, thank God, I was on the Mercy ships and we could intubate the patient and take care of them, and they did fine, and we did the surgery. That was the last retrobulbar I ever did on a mission trip, and I've gone to peribulbar, and I love this idea. I think it's a great idea. Like Gene, I've had a lot of trouble. I've tried it and had a lot of trouble with akinesia. And I think in a situation where I can't communicate well and the patient doesn't know, I'm a little reluctant. But I love the idea, and I love that thought of bringing that technology back, and I hope that maybe something will come out of this where we can have something less invasive. And I love the fact that it's really quick. You can do it right there, that you don't need 20 minutes to prepare, and then the fact they recover vision so quickly, I think that's a great idea, and hopefully something of this nature will develop it. Thank you.
Absolutely. Yeah, I would say too, because this doesn't require as much sedation as a traditional peribulbar or retrobulbar, I think your communication might actually be better in many cases because you're not having to wait for the patient to wake up from their propofol, and you're not having to heavily sedate them with benzodiazepines before the blocks. So your patient's going to be a little bit more consistently alert. So even if there is a language barrier, obviously I don't know how everyone's mission is, but for our work that we do in Haiti, we always have a translator that's standing right next to us.
So Abe, Americans are weenies. Africans are tough. So when we give them blocks, we don't give them any sedation, and they are just fine. They're tough.
That's hardcore.
But as a final comment, I would say that if akinesia has a problem with what Dr. Jacob's doing, I think it's never a problem. Even before the eye recovers, I think the patient is out of the OR. It'll be great to combine this technique with the 90 seconds of what Dr. Jacob is able to do, the help of the Lord. I think that'll be fantastic. So, thank you.
All right, thank you for your consideration.
Takes me longer. Thank you, Abe.
Now entering the Shark Tank is Dr. Ken Friedman from West Texas. He has developed a simple application to aid diagnosis on the mission field.
Good morning. I'd like to tell you about something that kind of developed on its own. And if we could go ahead and start the PowerPoint. Okay, very good. About 4 years ago, I spoke to the Society about the missions organization that I was part of called Global Scholars, which sends university professors around the world, Christian professors, to various institutions and universities, a sort of academic missions where the idea is to influence future leaders in countries. And so I teach at Texas Tech. I teach residents. And anyway, it's tough being up here, presenting your innovation. But anyway, I took this responsibility to go to Cambodia, and I spent 9 months with my family in Cambodia. And during that time, I saw a great need among the fledgling residency program there for just the basics. I was there to teach neuro-ophthalmology, ocular plastics, strabismus, but I could see they really needed the fundamentals. So I started writing down these lists of differential diagnoses. And I thought, kind of after the originator was Hampton Roy, who had his book of differential diagnoses. But I went ahead and started putting them into a PowerPoint presentation. And it was an ongoing project that began in Cambodia. But when I came back to the States, I continued to put it together, and then I saved it as a PDF. And I found out how to put links at the beginning of the presentation to go to each slide in the presentation. And so I started giving it to the residents and just saying, here, I want you to, when you're in clinic, think through different signs and symptoms that you see. And so here's the presentation right here. And credits and how to use the program. And basically, the next 4 slides show different links to different differential diagnoses within the program. And if I could get you just to take the pointer and pick one of those, just click on one of those links. Well, no, I need him to actually click a link for me. Why don't you hit like, there we go, eyelid mount positions, ectropion. And this would give you the complete list of things to think about when you have a patient, say, that presents with an ectropion. Many patients have senile ectropions, but there are other causes for them, and I wanted the residents, both here and in Cambodia, to think about causes. So anyway, I had this PDF, and I gave it to the residents, and then one day in clinic in Cambodia, it was about 2013 or so, I just saw the resident take out their smartphone and had it right there, and she was flipping through looking for the differential on that patient that day. And here's a guy who never programmed an iPhone in his life, and here she's using it like an app on her phone. And so I'm continually working on developing this and putting links even on each slide so you can navigate the program and have right on your iPhone a list of differential diagnoses that you can use in clinic. And so that's my innovation.
Hey, so have you looked at other apps that do the same thing?
Oh, no, not yet.
Okay, there is one, iHandbook.
iHandbook. Yeah, well, I'm not saying this is necessarily original, but I think it needs, something like this needs to be out there and available.
Kent, I congratulate you. I think this is a valuable contribution. I know immediately I would turn it into Spanish because I think they need to see it. And I don't know if it's readily available, but I wrote a similar app for ophthalmic assistants. And for a long time I was trying to make it available to everyone, and I got the American Academy and the Pan American to just put it on their website, and now anybody can get access to it for free. So I highly recommend you do something like that as well.
I must congratulate you on the simplicity and the impact that is already creating, right? You're very focused that I want them to think of a differential. It is so easy, a PDF can open on any phone. You're able to hyperlink, which I think is very beautiful, that they are able to go back and then go exactly where they need to. And I think it's just as Juan mentioned, I think the possibility for this to go multilingual is amazing, right? And if you are able to just put it on a website where people can just come and download these PDFs anywhere in the world, I think it will go a long way in helping people think alternatively about what they're seeing as well. I think it's brilliant. Please continue to expand your repository of content.
Thank you. Yeah, I think this is a terrific idea. And Ken, you might be able to educate me. If it's a PDF, I don't think it's dependent on Wi-Fi, is it?
You're not talking to a computer geek here.
I don't know.
I don't know.
But a lot of the places we go, you just can't get Wi-Fi. And having something like this.
Oh, yes. This is something you could download to your phone. I mean, you can send it. I've sent it by email to the residents. It's only an attachment that's maybe 5 or 6 megs. You just download it to your phone, and it's not dependent on being connected. That's right.
That's fantastic. And I know I've carried on my computer, they have the different Dwayne's, or they have but this is really a phenomenal thing. I think it's a great idea.
I offer to translate it for free, as long as you can get it
To Spanish?
Yeah.
Oh, well, we'll connect.
Get a link, put it out there, let people download it from around the world. All the best.
Okay.
Now entering the Shark Tank, Mr. Sam Powdrell, physician assistant from Wilmore, Kentucky. He has developed an innovative lighting system for portable microscopes.
Good morning, COS Sharks. I've worked on a lighting system for my microscope, and so this morning I cannibalized my microscope so I could actually show you the lighting system. So while they're putting it together, The actual lighting system for the whole microscope is right there. So this has saved a lot of weight, and the reason is we're looking at a dual axis lighting system designed to help with mission microscopes. And the reason we're looking at that, which way do I hit this? Okay, wait, okay, I get it right. So I want to ask you, do you have red reflex? Most of you operate with the most amazing red reflexes, but your microscope weighs 400 or 500 pounds. So when you want to go on a mission trip, you can't take that with you. You can't go anywhere. And so the red reflex is important when you try to cut that weight. Okay, so a basic system looks sort of like this. You've got your binocular here, and then a good system has a nice parallel optical system and then focuses with the objective lens onto your eye that you're operating on. The lighting system somehow has to follow that track. And so this is what we've done. Most of the big scopes use some sort of a beam splitter. But to cut weight and to have less light and still get the same result, you use a coaxial system that's parallel and then focuses down onto the eye. And so that's what this is doing. So the parallel design sort of looks like this. It has a double source. So there's two LEDs in this, one there, comes through here, has a mirror, and it gives us, by the double system, in the same line as the optics, it gives you the opportunity to get a close to coaxial red reflex. There's the system, and this is it right here. So there's the system that we're looking at. So I want to just show you what it runs on. So also to cut weight, and if you've ever operated in the bush, which I did for a long time and was the impetus for doing this, this is what it runs on. 15 hours of operating time on this. And I do this at the risk of technology going bad when you give a talk. That never fails. But there's your light source. And those are the two bulbs. And you'll see there's a little bit of difference in the size of them, where the focus is. That's because the little offset between them, and the objective lens focuses that right when you're in focus on the eye, and gives you that coaxial light and a nice red reflex. So how do we test the red reflex? Let me look at those innovations just for a second. So it's lightweight. Halogen is expensive. It has a heavy light system. It has a heavy transformer, often delivered with a fiber optic system that in Africa always gets kinked and breaks the little fibers. This system has lighting systems similar in color to the halogen. It's one of the lowest LED UV outputs of the LED bulbs available. It's battery operated, as I showed you. Low heat generation. I actually use the microscope itself to dissipate the heat because it's aluminum. And then because there's two bulbs, if an LED probably will not go out in your lifetime of operating, but if it does, there's two bulbs and you'll still have light if one of them goes out. So it's a parallel system. Okay, so what does all that come down to? An improved red reflex with a lightweight system. So single axis, I started out with that where the light was just between the two objectives. Now we're going to the dual axis over there. And so this is our beginning. This is what we looked at. Now this is a very unforgiving red reflex. Welch Allyn gives these so that you can learn how to use your ophthalmoscope for beginners. But I found it's useful for checking my red reflex. And so I can actually look with this, but it's unforgiving because the pigment epithelium in the eye dissipates that red and helps you, but this doesn't. So you'll see my original one had a very small red reflex, and this was dark. When you put the other eye, so this is only from one ocular, if you put the other one, you would have something like this. So think of that as we do the next slides, because they're all just from one side. So there's a dual axis system. You can see how the red reflex has been improved with that system. There's my dual axis system compared with the Zeiss M6 scope. And so you can see with a low cost, low heat, low weight system, we've got something that approaches the M6 Zeiss. So it gives you the opportunity to operate in the field with a microscope that you can put in a suitcase that weighs 50 pounds, you can take on the airplane with you to do your mission trip. And I hope that each of you will take the opportunity to buy one of these microscopes, take it on a mission trip, and do something good for those that don't have the opportunity of having vision. And with a good red reflex, your result will be good too. So what I'm asking you to do, use one of these microscopes, do something good, and thank you for listening.
So tell us a little bit about cost, number one, and number two, tell us about the battery life.
So the cost is very low. This allows us to, it's simple technology that put in the microscope. The cost for the microscope, which we've been developing, and I say that Stan made me do this because Stan actually helps me with this project. So the cost is low, and it's very competitive with anything else that's on the market that's lightweight. As far as the battery life, it's lithium ion. Those have a life. When they go, they really go. But that you can see that's small enough. You could take 2 of those with you to a mission trip, charge one during the day, and when you've got electricity. When you don't, you've got 15 hours of operating time.
I would like to commend you and congratulate you for your efforts. As I was listening to you, this individual came to my mind. His name was Robert Welsh. And for the
Yes.
older crew, they remember the Bob Welsh microscope, and he would carry around his case. And I can even remember the way he would talk. Say, Juan, when you go down there to Santo Domingo, you need a microscope. And you need to be able to do microsurgery. They're only using 8/0 silk. And the fact is that the Welsh microscope, like yours, could probably do revolutionized ophthalmology in my country because they saw for the first time through a microscope. Now, of course, they all have size 700s and the like because they enjoy seeing so much better. But I know that in the mission field, if you need to have a lightweight, if you're going on a outreach program, Diego, that when he goes into Honduras or into the boondocks of Guatemala or El Salvador, this is the way to go, or even in Africa or anywhere.
The Welsh microscope was actually one. The pictures of that scope were actually some of my initial interest in doing this project. So.
First of all, hearty congratulations on the innovation and stuff. I'm interested to look at the current progress right now in terms of scale. Where all you've been able to put this innovation currently, and how is their feedback feeding back into you for refinement? Any thoughts on that?
Yes, absolutely. So you saw I went from the single axis to the dual axis. A lot of that has been based on ophthalmologist feedback. This microscope is in Nepal, Ethiopia. It's in Ghana. I've used it in Ecuador and Central America. Several others that are here have been using it in other countries as well. And we've had a lot of feedback from M6 surgeons that are doing a lot of M6. So,
Congratulations, that's all I have to say.
Sam, I think, again, this is one of those ideas that's, I think, really, its time has come and it's great. For anybody that's out there that's ever had to finish a case by flashlight because your electricity went out, having the battery source, I think, is genius and is really helpful. The other thing about your scope that, again, if you don't think about it, that's very important is they can get the tripod and the scope in one case for under 50 pounds, which means that I don't have to pay extra to have my tripod traveling with my microscope when I go through the airport. And they used to give you a courtesy for mission trips, but very few of them do anymore, and so it just saves some money, and I like that idea. It's very good.
we're constantly looking at ways to reduce our weight. We actually have a video system that goes in that same system. I didn't say that actually helps you with teaching, and all of that's still under 50 pounds, and I keep every month reducing that weight somehow.
Thank you, Sam.
Now entering the Shark Tank is Dr. Alex Young, a PGY4 from Baylor University. He has an innovative idea for ROP screening using a cell phone.
The title is Easy ROP. Hi everybody, I'm Alex. It's a pleasure to be here from Houston. And I wanted to talk first about, let's say you are an ROP screener and you get an email with this image up here as an attachment and you think, hey, that's a nice photo. How did you obtain it? And I tell you, this was taken with a 20 diopter lens. Not bad. It's got the nerve, it's got the macula, the periphery. It really is a wide field, in fact 152 degrees wide. What if I told you that it was from a smartphone? And you say, wow, that's actually really good quality. But what if I told you a minimally trained photographer simply walked up to the patient, quickly placed the device on them, and took this picture through this pupil without dilation? This is exciting. This is really exciting. And you might think, hold on, what about simple smartphone fundus photography? You use a phone and a 20 diopter lens and you get this nice picture of plus disease, but you need an army to do it. And I counted 6 hands, feeling like there are too many fingers around this tiny baby's head. It also gets tedious to get in the right position over the crib, over the baby, and only gives you a maximum of 55 degrees of view. And this is with dilation. You might also say, what about the ret cam? Well, it's a little pricey and upkeep costs. What's not written in there is having trained repair personnel, especially for donated machines in a low resource setting, is an absolute challenge. In addition, image quality is a problem. Although good images give you about 85% sensitivity with the ret cam, once you have a poor image, which is in the experience of the operators in my own institution is actually quite common, causes the sensitivity to go down to unacceptable levels. And looking at just this picture here, you can see there is zone 1 disease inferiorly, but the vessel architecture where the question marks are isn't great. And there's literally a shadow over the macula because of the necessity of the optics. Why this happens helps us lead to an alternative solution. This occurs because of Goldstrands. Fathers of optics realized that the light path into the eye cannot be the same for the imaging path out. And so the illumination, as you can see in that green circle there, just like all our fundus images, needs to be by necessity around and away from the imaging light path. And that's why we need to dilate the eye. But what if your light source was elsewhere and your pupil was totally dedicated for your imaging path? Instead of the light delivery system being around the pupil, it's transscleral. And note here, your field of view increases significantly. Using an optical fiber that transmits a warm white LED light through the avascular pars plana, one can illuminate the eye like a lamp. And no one takes a lamp and puts it under a basket, but puts it on a stand and gives it light to the whole house. And now this technology has been done before. We're talking about legacy. The Panoret 1000, which produced amazing images in the early 2000s, had an unwieldy camera in one hand, the light source in the other, and a foot pedal to boot. And it made it great if you're a Ringo Starr, but it's hard for anyone less coordinated. It didn't do well successfully. These new ideas for illuminating transsclerally are a little bit cumbersome. So I think this technology is about putting the pieces together and integrating this basic science technology that's just been sitting around for decades and connecting it with the end user ergonomics with design principles. In other words, in learning from the failure of the challenging operation of the Panaret 1000, can we take this technology and make it easy for the end user? And I think we can. The solution is that the whole device has to be one integrated piece. And the movement for the operator is, I think, especially in the pediatric world, a contact lens with a quadrispheric lens that sits in the same housing device as the light probe fiber optic that fits over the pars plana. Not at all different from the CPC probe that you can see there. This is then housed onto a smartphone, and the laser goes to a clip-on battery and LED generator. And with one easy contact, you could potentially put it on an infant's eye all in one piece. Right now, putting this together is an idea ripe for proof of concept. But what transscleral illumination offers with non-mydriatic, low-cost, high-quality method for teleimaging for ROP, this can make screening more accessible in remote and underserved locations. And I'm really excited about its potential. I think somebody once said that in every doctor's brain there's an idea. And it's all about making it a reality. Thinking about this idea, I'm definitely on the excitement phase. I'm not ready to go down. But what I realize is thinking about all of the fun and challenging struggles and hurdles to develop a process like this, to make it easy for the end user and to have a good results, it's all about the sacrifice that's put in by the innovator. It's not just about it taking it, and I really actually think of Jesus taking on the sacrifice to make it easy for us to love him. It wasn't the other way around. And so thank you to you all for listening to this and cultivating a culture of ambition for God's glory. Thank you.
Wow. I've tried every one of those gadgets that you've already mentioned, and I know Danielle, who did his thesis on ROP, is all excited about this. But just so you know the impact that this may have, in the Dominican Republic, before we had screening for ROP, the School for the Blind was just filled every year with 400 new blind children with ROP. And the reason was that we were rescuing those babies because we had very good neonatal services, and therefore they were surviving. But the obstetricians and the pediatricians had no idea that there was this disease called ROP that could blind them. I mean, we would get them at 6 months of age, and it was too late. And finally, we had a program to change that attitude that was as important as the fact that we had to teach all the people how to do the indirect ophthalmoscopy. We have a kangaroo program and the like. So then we looked at the red cam to see if we could use it, but $100,000 is out of the question. I mean, the whole program, I think in 5 years, uses that amount of money. And something like this, I promise you, would revolutionize screening for ROP in the world. I promise you.
Great presentation. Question. So the contact lens that you talked about, is that, how do you sterilize that between patient eyes?
The contact lenses used now, you're right, sterility would be an issue, except that at the VA that I go to, the contact lenses are actually disposable. So one of the ideas is just having a new contact lens that's been put on. One of the challenges too is that if you have a permanent lens, if the inside surface of the lens that's housed inside the device gets dusty or dirty, then you start to have to talk about maintenance to try and clean it off. But if you use disposable, not only are they cheap, but you can avoid that problem.
Number one, keep that duende there. It's amazing, right? While you were going through your presentation, I was really wanting to know more and more and more. The way you beautifully presented is just brilliant. Couple of thoughts. Number one, you have a wonderful idea that you want to test. Number two, gather people around you who will be able to help you achieve that. Today in the world, you have this access to a very, very multidisciplinary, diverse team. If it's fine for you, go to hackathons where there's hardware in place, work with teams, quickly get your proof of concept out there into something that you can further kind of work on, right? And of course, when you go down the path of a hardware device, it is quite long in terms of certification, in terms of refinement, funding, and everything. I'm pretty sure God will provide you all of that in due course of time. As a matter of fact, next week I'm starting development of a digital system for ROP back home and also for the country at large. And I look forward to integrating your device when it's ready into that. God bless.
I'll see you there.
Yes. Congratulations.
Yeah, this is a great example of what we're looking for, is just taking something like a phone and transforming literally lives. And you know, one of the most frustrating things for all of us is when you go around the world and you see things that you could have fixed back home but are too late now to fix. And this gives us the potential to identify things that can maybe then develop a chain where we can actually do some treatment to prevent filling up these hospitals like Juan was talking about with kids that just can't see. I commend you. It's a great idea.
Okay. Thank you very much.
Thank you.
Now entering the Shark Tank, Dr. Jason Ling of Washington State. He has developed a portable, low-cost vitrector.
Hello, everyone. I have a PowerPoint. So this journey has really been a testimony of how God's worked in my life, so I just wanted to share the journey and the process. So it's been a burden on my heart for many years, high-speed vitrectomy in the mission setting. About 2 years, I spend as much time as I can in my vacation to go on missions. About 2 years ago, or maybe a year and a half, we were coming back from North Korea, and there were some cases, complex cases, sublux lens and stuff. I really wanted to do more, but we didn't have a vitrectomy, and it just bothered me. It's like, I really want to do more, and I need to have some type of vitrectomy solution for complications and also complex, and to do more in-depth cases. I wanted to handle things better than just a scissor vitrectomy that we've been doing for years, and I started looking. All the available machines were either the size of your fridge, also really, really expensive, and most of them are both. So I went to look for more portable and cheaper solutions, and the only couple I found that were available on the market was one made in India, the one on the left. So I went to the booth at Academy, at Apasami, and they had a machine there. So I kind of asked them, and they're like, oh, it's not really for sale for India, but some for people who want to do mission stuff. That machine was about, this big, like an old 1990s PC, maybe bigger. There were some limitations. The cut rate was only 600 cut rate. And I said, where do you get your handpieces? And they're like, we don't manufacture handpieces in India. There's too high precision. They're all imported, US or Europe. So I kind of put that on hold. Then the machine on the right is actually a small, nice portable machine. It's electric driven, and a small company by Insight, and this was called the Intractor. Maybe you guys have heard of it or seen it. But the cut rate was about $12.50, not bad, but that was one limitation. Also, the cost was a little bit high. It was close to, almost $10,000. Maybe you get a discount if you're a missionary. The handpieces was what bothered me the most, because it was proprietary. You could only get it from them, and it was a small company. I'm like, well, there's going to be support, and I just checked yesterday, and they sold the company to Oculus, and it's not even listed anymore. So I don't even know they're making it. So it was kind of good that I didn't venture and invest in that product. The machine we have at home for phaco and anterior vitrectomy is an older machine. This is a Sovereign Compact Unit by AMO. It's a machine I use on a daily basis. And the retractor on that it's an electric rotary cutter that cuts at 600 cuts, and is really not ideal. Even I always felt bad when I had a complication and had to use a retractor even at home. The probes are really large. They really wouldn't fit through a paracentesis. Cuts are slow. The handpieces would fail, and they're really expensive. You know, even an old handpiece like that was a couple, $1,000 to $2,000 to get a replacement. And most of the retractors at the time when I was looking about 2 years ago were at this style, pneumatic driven, guillotine style. Most people are very familiar with this type of handpiece. So I was like, there's nothing out there. So I decided to take a leap of faith and venture to build one. And like, am I crazy? You know, on my wish list, I wanted something that's high speed, a guillotine retractor, that's something that I can carry around, is portable, and has a good support where I can buy disposable supplies, reusable supplies, and for handpieces and such. And I love this quote, I can do all things through Christ who gives me strength. And I'm not quoting this in a presumptuous way, because I know that I won't ever be able to lift a car, but in a more of an open way, where in Isaiah it says, "Here I am, Lord, send me." I'm willing. I don't really know how I'm going to do it, but I'm willing if you can empower me. Now, just to give a background, I have no engineering background. I'm a biology major. When I was in college, I was kind of useless, right? I have no idea how they work. I don't know electronics. So these are the things, my barriers. I needed to study how the guillotine retractors work. I need to study how electronics and circuitry work. Only thing I remember was like Ohm's law from physics I studied for the MCAT. I didn't know, I'm not a programmer, I didn't know computer code. I knew I had to write some kind of software. I didn't know about pneumatics. I didn't know machining. I didn't know how to use CAD. I didn't even know what kind of parts are out there. But thanks to YouTube and Google University, I felt that I could learn anything, So this is a journey. And maybe I was biting off more than I could chew. But I showed a series of pictures yesterday, and I talked about thinking outside the box. And then going on these mission trips, watching Dr. Jacob operate, doing something with almost nothing kind of inspired me to do something more. So I started working in my office. Now I had bought some eBay microscopes for missions, and they were just stored in my office. Everyone passing my office would laugh at me because I had these, you could barely walk in my office. Had these scopes. I'm like, well, since they're sitting here and I haven't used them, I'm also using them for learning how to solder circuitry boards. So I started just practicing soldering pins, reading a lot online about how to code electronics. So this is about late 2016. So we came back from our North Korea trip in September. So I started working on it soon after, about a month or two after. So after a long days of work, I would just stay late nights in my office and just keep working when everybody left. About a couple months later, I came up with my first prototype board. So, like I said, no background experience. I'm like reading forums, tutorials, trying to figure this out. So this is my very basic board, and I had to solder every connection by hand. There's no printed board because it's all concept. So I wanted to make it small and portable. So I, bench, and I don't have access to a lab. And maybe I should have reached out to the hacker community or friends, but I'm more of an introvert, so I was like, okay, I got to do this all myself, So I was just doing this just in my office and at home. So this is my first prototype, and I had to put it in some kind of box. So I had an Altoids box laying around, so I stuffed it in that, and I realized that first that the Altoids box is metal, so some of my first prototypes got messed up because it wasn't grounded properly. So. You have that up phase, and you talked about the down phase. Yeah, there's a lot of down phases where I was like, oh, that didn't work. But so this is my initial prototype, and it looked kind of ridiculous. There's a whole bunch of tubes and gauges and power supplies and wires, and I'm like, I have no idea what I'm doing, but I'm learning, and God's teaching me. So actually, I wasn't going on a mission trip for several months, and that burden, I was starting to do a lot of complex cases at home. Trauma, cataracts, sublux lenses. I was doing pretty much secondary IOLs, glued IOLs, skull fixated IOLs on a weekly basis. And, there's vitreous in the AC to begin with in a lot of those cases, and I just felt bad using that old 600 cut rotary cutter that just seemed to be just winding up the vitreous in the handpiece, So I told the staff, I was like, I've done a lot of testing, I'm going to bring this into the OR. So I just take this whole pile of tubes, plop it on top of their phaco machine, And at that point, it wasn't quite refined yet. I had two pedals, one for the phaco and one for fluidics. And the second one was to run the cutter. And we actually did a few cases, and it worked great, thanks to God. Then I kind of moved my office work so I could work at home more. So here I am working. This is my kitchen counter. So I think I'm soldering a circuit board there. And so there's a lot of stuff I've just been learning and working on my computer. But God's really taught me. I didn't want to spend thousands of dollars on CAD software, so I was like, Google, what's free CAD software out there? So I downloaded like 5 or 6 different CAD software out there, and some of them were way too complicated, and I found one that actually works. So finally I just, found a box that I would use and had learned how to machine, how I can give instructions through the CAD to the machinist to be able to cut custom holes and that kind of stuff. I learned how to design a circuit board, and so this is my very first circuit board design. I got manufactured here in the US. And when I was walking, I think I was in Academy or ASCRS, I can't remember one of the meetings, a few months later. Then I walked past the Alcon booth and the Constellation, nice, crazy expensive machine. And so they're comparing the Ultravit probe to the Cruise probe. And they would call it port optimization, where in normal guillotine cutters, you would close the cutter and open the cutter. So you have a 50% the time of the cycle when it's closed, and 50% when it's open. Okay, so that works, and that's how most of their anterior vitrectomies on your phaco machines work. But I wanted something more, since I'm already spending the time, I also make something good, So they called it port optimization, where you can stagger the cut, so you can see on the right side, the port is, that is an open biased port optimization, okay? And the other one is just 50-50, okay? So I decided, well, it's just a matter of code. So I struggled with the code. Again, I'm not a programmer. This is the first time I'm learning code. Programming, and I was like, finally I found, what the timing was. So I came out about a 70-30 ratio, and I might have switched it to 60-40. So, and the reason why you want to have an open port bias is that you can speed up the efficiency of vitrectomy, because you can open, aspirate more material, and cut. But you can still have a high cut rate. So for retina specialists, I'm not a retina specialist, but what they say is, if you're going for a bulk vitrectomy, you want open port bias, and if you're really going fine-tuned shaving near the macula or something, then you want a closed bias, where majority of it's closed so that it's very fine-tuned. Again, no testing equipment. I had to test all pressures, everything by trial and error. I hooked up my iPhone. I wanted this high-speed camera to be able to visually confirm that my testing was correct. So I was like, where am I going to find a high-speed camera? I'm going to maybe rent one. So I'm like, wait, my iPhone has high-speed a little bit, right? So I'm like, okay, I clamped the vitrectomy handpiece and focused my microscope on my office, and then put my iPhone and then hold my breath. And 240 frames per second, I can slow down 10 times. Then I could confirm that the cutter, and this is in slow motion at 2,000 cut rate, that the cutter was actually completely closing and opening. And you can kind of see, let me repeat that it's a staggered cut. So it's a open port bias. So this is, okay, so mine end of September, my first kind of prototype-ish made by March. And then this is my first mission trip, 2017 in Guatemala of May. Brought it there and it was working. At the same time, my boss is also a really big innovator, and he has way more knowledge than I did. So I was like, look, and I kind of wanted to keep a secret from him. And then, so finally I showed him, I was like, this is this machine. And what I actually had done is, since our phaco machine was had an old-fashioned cutter, by trial and error, I was like, oh, there's a serial communications port out of the back of my phaco machine. So I bought some cables and hooked up to my laptop and tried all sorts of things, and they just pumped out a bunch of numbers, but finally I was able to decipher like what number was actually meaning what. So in my first version, I had built in the software to communicate with our current phaco machine so that I could plug it in, bypass the old rotary cutter, use my high-speed 2,000 cut per minute cutter, guillotine cutter, and still use the fluidics on our phaco machine. So here it is on the left side, just put it on the side and hook up the serial port, and it would communicate. So my boss got excited. We have about 30 ORs in 6 different states. And so he's like, let me see, so I shared with him the design. So he's like, he loves building. So he built pretty much the primary parts are based on the ones I've chose. He wanted to do his own software design because the code, but the core components are about the same. So we have one in every OR, in 30 I think about 30 of our ORs, on which we are using on a daily basis for almost a year. So I refined it a little bit more. Had to learn a little bit of design, silk screening. I got some inspiration by Apple to make it simple. I wanted it nice. It's a one-body anodized aluminum body with caps on each end. It's only one knob. There's only one connector that anything can fit into, and its simplicity is key. There's one light bulb, and I'll show you how it works. So it comes in a case like this. It's very light. Runs off a portable air compressor. I wanted something quiet, and I actually found that compressor when I was daydreaming at 3 in the morning, trying to find a good air source that wasn't really expensive. And I just thought of it, and then I gave me an idea at 3 in the morning. So this will actually, my unit will actually run 110 to 240 power. Unfortunately, the compressors are AC. Sorry. Compressors are AC, so that you can either get a 240 or a 120 unit. So this is, get this out of the way. I wanted to make it really easy, so quick release on everything. Plug it in, snap. You can get a longer cable if you wish. So the port in the back is just air, a reset button, and power. So you notice the light is blue there. There's only one light bulb there. There's actually a pressure indicator. Now the compressor's not on. Blue means it's too low, the pressure. So it's so these pedals I got and actually custom built the wire into them. So these are run off of guillotine retractor cutters made by Midlabs. Midlabs, anything that looks kind of like this classic style like this is made by Midlabs, even though Alcon or AMO or other companies have it branded. They're all made by the same company, they're just sourced. Okay. So usually on your retractor cutter, there's green you connect to the machine. So you connect it here. And then turn on the compressor. Very quiet, you don't really hear it, right? So now the light turns green, okay? So what happens when the pressure is too low, like for some reason, this should always say constant. It goes too low, automatically turn blue. That's pretty easy. Okay, what if it's too high? If it's too high, then it'll turn red, okay? So it's very easy just to look across the room, and when it's green, then we are good, okay? So there's, I originally wanted to have a bunch of settings with a screen and everything, but I figured it's more robust, less things that can go wrong. So I only have 4 speed settings, and I don't really see a need for, in the mission setting, to need more than 4. There's a 100 cut rate for PIs and that kind of work. There's 600, 1200, and 2000 cut rate. And the reason why I would use a slower cut rate would be to cut like membranes and like fibrotic capsules. It's kind of like a Simcoe retractor. So you just hook up, obviously you wouldn't use a syringe this big, right? This is the one I had laying around. Hook it up, you can Simcoe to the port, you step on the pedal. So you can't really hear it because that's a 100 cut rate. Here's all the way up to 2000 cut rate. Very quiet. It's cutting at 2000 cuts. And as long as it stays green, it should be good. And even though Midlabs makes all these, every manufacturer likes to make it proprietary. So It will work with Alcon, old Alcon Cruise handpieces, which they don't make anymore. I had a whole bunch. You just have to cut the connectors and re-splice them, but it's very easy. And the pressure is a little bit different, and you can just dial the pressure, whatever you want. So let me just give you the specs again for the machine. One piece anodized aluminum, quick release connections, cut rate max at this machine is 2,000. It's actually limited by the handpiece and not by the unit. If it's all software, so I can actually make this thing cut at 8,000 cut rate if I wanted to. But the handpieces that are 8,000 cut rate are actually really expensive, so I don't really think there is actually a need for an anterior retractor that's that high rate. 1,200 is and above is plenty sufficient. This unit is light, but with the compressor and the pedals and everything, is about 10 pounds. Unfortunately, the case that you can just throw around is also 10 pounds, so it ends up being 20 pounds. You know, I might be looking at lighter boxes, but one of my partners took one of my other prototypes to South Sudan just a few months ago. I brought this machine to Guatemala just 2 months ago, and we were able to do stuff that we've never done before. I did about 5 pediatric cataracts, bilateral, able to do posterior capsulotomies primarily after we did implant lens, complex cases, sublux lenses, and so it's a very useful machine that I found that has really opened doors to mission work. So, and again, retractor handpieces you can get in 23 gauge, 25 gauge, 20 gauge, probably 20 gauge. 23 is probably your choice for mission work because they're cheaper, and you can 20 gauge will actually aspirate faster because it's a larger bore. That's it. Thank you.
I'd love to see a genius. This is amazing to think this was done with an engineering background, and having worked with development of products similar to this, we needed 13 engineers and 13 doctors together to figure out how to do this. And Alcon, just so you know, just to do their constellation, used 3,000 engineers. But as you were talking, this history of vitrectomy surgery came to my mind, because Bob Mockelmer, and Steve knows about this, went to his garage and developed the first vitrector in his garage. And the first trial of a vitrector was with a pen that had a rotary cutting blade inside, and he needed something to try it on, and he did it on an egg. And of course, what Jean-Marie Perel did, of course, in engineering and developing the OMS and what we later on came to know as a vitrector, it was phenomenal. You've been able to accomplish this in 2 years. So this is not a minor accomplishment, it's big. My caution is that it is so good that you're going to have to face the FDA at some point and the patent offices. So you need to be prepared for monstrosity of obstacles along the way, unless you figure out another country where you can do it.
I want to say, wow, thank you. That is excellent. In the mission field, as you know, we commonly have a lot of barriers with regards to language and educational process. And as surgeons, we are typically in operating microscope mode, and we're staring through those, and we're not really looking at red, green, or blue lights. Is it possible to add some kind of a little noise component so that when it flips from green to blue or green to red, we are alerted? We're used to that. Our ears are trained to that. Is that going to add cost? And I don't mean that it should do that, but it might be helpful for mission settings where we have some language barriers.
Oh, that's very easy to do, and it'd be very cheap to do. I don't like annoying noises most of the time. The reason why there is even light to begin with is it's actually not that necessary. The tolerances are actually pretty close. So if it's green before you start, it'll stay green all day, okay? And you'll know when it doesn't cut, it just won't cut. And the compressor won't build more pressure than it's built. It might do lower if it's not working, but the moment you step on the pedal, you'll see the knife is not going. So there's not any danger to the patient at all. It's a matter if it works or not, but it's easy just to look across the room before you start, you sit down, and it's like, oh, it's green. That's all you really have to do. Most of the time it's under the table. I don't really care anyway. It's when it doesn't work, then you're like, oh, okay, it's blue. The compressor maybe got kicked and unplugged or something, or then you know, yeah. Mhm.
Well, I must give you a standing ovation. No,
By the glory of God.
it is amazing. Just to praise God. I praise God
Yeah, praise the Lord.
for the insight, for the skill, and for the passion that He's put in you to do this, right? And it's very special. Everything of your slide, I could see the struggle behind even getting at different things. And one of the things that's deeply touched me, I would definitely say what's really inspired me today is what I'm also going through right now, is that you learned something that is not even in your domain. And you went the distance, you learned it because on really and I only wish you the best as you scale this, as you take it into each and every OR to benefit millions of patients in the days to come. Other thing I wanted to ask, which Juan also kind of mentioned, is of course there will be obstacles on the way because it's absolutely not easy to build a hardware device to get it to the stage, and your detail for design and usability and everything is really inspirational. So I really praise God, thank God, and I wish many, many more innovations come through the work of your hands.
Thank you.
Congratulations.
Thank you.
Yeah. The one I built worked nothing like that at all. I mean, that's just, it's mind-blowing what you've done.
Yeah.
Or one question and a comment, maybe, or a hope. Are they available to buy and cost? And the second one is, do you have any kind of a video tutorial where you can show the things you're doing and how to use this and set it up? And that would be real helpful as well.
Yeah, I didn't know how much interest people would have on this thing because I built one for myself, and I was talking to my sister who's also an ophthalmologist, and they're like, well, I feel like I can serve better, but then they're like, well, maybe the other people might be interested, And I was just afraid. It was like, if I make 10, make 20, and sitting around my house doing nothing. So the cost will be definitely related to volume. I really wanted, I didn't do this for any money. I just wanted to be able to provide something to have people have a tool to give better care. Most of the machines are probably almost $10,000. I'm hoping, I'm still, parts are from Europe, from all over the world. Hopefully I can get it down to somewhere between 2,000 and 3,000. And that's the goal. And still, figuring that out. Of course, all the not fun stuff is all the paperwork and working on patents. This will be, I was like, oh, that's kind of exciting. I get to file my first patent. And FDA, I'm looking into FDA approval as well, but that's not the fun part.
But something that I would definitely say is that I think you should seriously start off looking at equipping yourself with people who are focused on doing those things.
Yes.
You will probably find very passionate people who believe in the cause. I'm pretty sure the Lord will help you find those people. Because as an innovator, what I see usually happens is that you get caught on to all of these other things that is not your domain and your expertise.
Yes.
And that will suck your energy, and you will not be able to actually focus on the true innovation and making it better. So I think with immediate effect, the moment you get back from cost, that's what I mean.
Yeah, that's very helpful.
I think you should really look at people. I'm happy to work with you to help you kind of find resource or probably see if there's people interested to help you design, because people did that for me in Oxford. The Lord put people around me to help do that, and I'm very happy to work with you to probably help you chart that path out of how many more people use this.
Yes.
There is a lot of need for this. Never ever think that there is no one who will.
Just an idea, who would be interested in a machine like this for a mission? Okay. Gotcha. The first name, I call it the V cube, the Vitrector cube, because it was a cube. That's the only thing I could think of at the time, so.
Yeah. How many want to buy stock in his company?
Now entering the Shark Tank is Dr. Nathan Henson of Cusco, Peru. He has a novel idea of how to fund mission efforts in South America.
Good morning, COS. It's good to be with you. So I'll try to get this in 5 minutes. But one of my colleagues is passing around a sheet for your name and email address, and I'll contact you to share more detailed information for those who might be interested in what we're doing in Cusco. So please sign up. So this is not a completely new idea, but I have not seen it being used much in Christian missions. So we've been serving in Cusco, Peru for about 8 years now. We have 4 ministry arms in Cusco: a clinic, a church plant, an orphanage run by my wife, and a university student ministry. The Lord's really blessed those, and we're looking for ways to sustain and even grow our capacity in those ministries while offering a real service to the poor. My primary area of ministry is in our clinic called La Fuente, where we offer a variety of services in addition to ophthalmology. The clinic will see around 30,000 patients this year. Even with those, we have a little bit of a different model. We try to limit the number of patients in order to pray with them, share the hope of the gospel with them, and impact them on a spiritual level. We also have medical students from 2 universities who rotate with us on a regular basis as a part of their training, so we need time to teach and to share the gospel with them also. We've had a good number of those students come to know Christ and be trained and discipled in our ministry, and who will be graduating soon, and we would like to hire them to practice the same type of Christ-centered medical care that we provide in our center. All this work and all these ministries require funding, and we'd like that funding to be generated locally. Because of our model of patient care and limiting our patients, it's difficult to generate the money necessary to sustain ourselves, and even more difficult to grow our capacity. We're proposing a refractive surgery program for missions as a model of sustainability and a new service for the poor. Refractive error is the #1 cause of visual impairment, inclusive of blindness in the world. Glasses are a solution, but they come with a cost. We often have to make and give away high prescriptions to the poor, and those can cost us up to $200 or more if we're talking about high prescriptions. Patients often lose or break them in manual labor environments. Traditionally, refractive surgery is thought of as a luxury for the rich, but it actually provides more benefit to the poor. Some can't get good jobs without good vision. An example of this would be we have a military and a police academy in our city, and those people are not allowed to pass the vision screening exam without glasses or contacts, or with glasses and contacts. So correcting a professional's vision does not increase their productivity very much, but correcting the vision of a truck driver, a manual labor, or as I mentioned, military or police, increases their job opportunities and productivity. A well-known refractive guy named Guy Kazarian, I've been talking with him a lot. He has an MBA. He's done economic models that show that if vision is corrected early in developing countries, or work for a person who's young, they can earn as much as $30,000 more over a period of 20 years. That may not sound like much, but in developing context, that's money for a university, a piece of land, a house. It can change the economic trajectory of a family. So Cusco is a city of about 1.5 million people in the region. The neighboring city, Arequipa, has about 1.5 million people as well, and they're both growing. Cusco is unique because of a powerful draw for tourism to Machu Picchu. There's about 3.5 million tourists a year that come through Cusco to go to Machu Picchu. This has resulted in a huge growth of business opportunities and jobs, and that's resulted in a huge growth of middle and upper class. The proof of that is that there was a successful high-end mall that was built recently that's been wildly successful. And because of that, we've reached out more recently over social media and have captured more patients on the upper and middle class end to subsidize care for the poor. These patients want refractive surgery. We've done surveys confirming that demand does exist and is actually very high. The biggest challenge is the cost of the laser systems, but as Stan was mentioning, we've negotiated what we believe to be a good deal with the laser companies, and they've offered us, as he said, no click fees and no maintenance costs for 2 years to get on our feet. The biggest piece of this project, though, is creating an open source laser system that can be rented by others. This year, I helped to create a society for all the ophthalmologists in Cusco. When I started, there were 5 of us in Cusco. Now there's 16. Our goal long term is to teach them to do refractive surgery and rent the laser back to them. We're currently looking for trainers to do that, but already have some agreements for that. Our business model indicates that if we were able to have 10 surgeons doing 2 cases per week, the business could generate $500,000 per year. That would sustain all of our current ministries and allow us to expand them. This would also open up new possibilities for funding new works, new missionaries, new La Fuente centers around Cusco, staffed by our new believing graduates. New innovations like the ones we're talking about today often require funding, and this could provide that. We believe this could be a model of missions to take elsewhere, looking for similar demographics and markets that have not been touched by refractive surgery, and use that technology as a local missions generator to fund churches, clinics, schools, orphanages, new mission teams going out. This also allows for a model like ours in our clinic because they're not completely dependent on me seeing 100 patients a day to generate the funding necessary to sustain the clinic. So I'm able to share the gospel and even do more surgical cases for low cost or while funding is being generated from the open source laser system. So right now we're looking for people to join us in this project. We need trainers who are willing to come down to operate with us. We also need some funding. We've raised a good amount, but we need about $200,000 more. So like the traditional Shark Tank, I'm actually looking for some funding help. Please consider joining with us in this project to serve the poor, to advance the gospel, to grow God's church, and to prove this model so that it can be used elsewhere in Christian missions.
Thank you, Nathan.
So here, Nathan, Juan Batlle is speaking. As you know, I live in Santo Domingo, and actually one of my students is up with you in Cusco, Christian Becker. Nathan, my comment is that
yes, he is.
It's just a warning. Can you hear me? Is there a
yes?
Is he following? Good. It's just a warning, because as long as you're doing cataracts and treating the patients with blind and disease, you're probably in a safe haven. When you get into refractive surgery, there's a bit of the cosmetic aspect to refractive surgery, and the hype and the plush and the jet set, and it's very hard in mission clinics to separate the haves from the have-nots. And what you will buy, you think you're getting additional income to help those who cannot pay, but you're buying, and it's just a warning, you're buying probably politically bad sentiments from the people that are in practice, not only in Cusco, but maybe in Lima, where you're going to be competing with them. And there will be a reaction. It's just a warning.
Sure, I appreciate that comment. I've actually talked to the local physicians, pretty much all of them, and they're really excited about being involved in the project. It's going to be a huge financial benefit for them. It's actually creating more of a connection for me with them. And these are guys that I want to reach with the gospel as well. And so I can say at least the local Cusco community is super excited in terms of the ophthalmologists. This will benefit them in a way that they've never benefited before in terms of economically and in training as well. They appreciate the training aspect.
Nathan, it's Jean. I'm a refractive surgeon from Oklahoma.
Mm-hmm.
I really enjoyed your presentation and your idea. But, it's refractive surgery is, as Juan was saying, it's just a whole different conundrum with our patient base. How many of these have you done, and how is the word getting out? Because what you don't want to have happen, of course, is infection, problems with the flap, etc., because that will shut down your whole concept right there.
Yeah, so that's a good question. I haven't done a whole lot of refractive surgery, but that's part of the project's design. The project design would be that first trainee would be me. So I'm asking for refractive surgeons to come down and work with me, train me. We're not talking about opening a refractive surgery program and bang, go. It's gonna be a slower uptake. So I'd be the first trainee. So I would definitely need some help with that. As I've talked to a lot of refractive surgeons, the number one thing starting is choosing the correct patients. And so patient selection is going to be a big part of this, particularly in the beginning. And then we would have a standard that we would require for other surgeons who would want to participate in terms of their understanding and their training. Yeah, I agree. We have to be very careful about it, but I do think that that it has high potential for, like I said, for serving the poor and for generating revenue. I think that the training is important, and we do plan to do that. I hope that answers your question.
Yeah, Nathan, thanks for your presentation. Well, I couldn't agree more with Juan and Jean right here. I think selection of the right patient, setting the expectations, and using this as a powerful tool to generate revenue to serve more people and help in advancing the gospel, I think is key. And I think it is a model that you will evolve and you will learn when you put it in practice. I think your discretion and your judgment on who needs to get it and who does not, I think will eventually evolve. And keep praying to the Lord, and I'm pretty sure the Lord will lead you on how you will scale this in the future.
Nathan, my only comment would be that in the refractive area, well, in all of our areas, we're aiming for excellence in what we do as a representation of who we are in Christ, and we don't want to offer anything that's subpar. And in the refractive area, it changes so rapidly that offering state-of-the-art type of stuff, I don't know that buying one laser is going to be a long-term solution, because they just change so fast, and the standard of care becomes different. So again, that's something to put into your model and look at that. But I love what you're doing. I think it's a great idea. It's just different when you're, as Juan said, when you're marketing a product as opposed to taking care of sick people that are blind. But I love the thought.
Yeah, so this is not, as I said, it's not a completely new model. I mean, it has been done in the Himalayan Cataract Project. There are other places that are doing this as well in India, and I think that the only difference in this project presentation is that it's being done in advance of Christian missions, and so I think it's actually a product it's a thing that's been proven to be beneficial and to work as a model. But I just don't see it being used in our area. And I do understand the need to take care. I mean, I take care of a lot of sick people and do cataract surgery and glaucoma surgery and everything that walks in the door. But as I said, we're looking for ways to make these mission initiatives sustainable, and particularly with our model in terms of, like I said, trying to use this as a platform to advance the gospel and to share the gospel. That's very challenging to have developing clinic work that is sustainable unless you're seeing massive volumes, and that doesn't give you time to do the things I'm talking about.
Absolutely. Thank you very much. Please remember to go to the link on the app as far as looking and grading each of the 6. There's also 4 more video presentations that I please want to encourage you to look at. These have been beyond expectation. I want to certainly thank the esteemed panel of sharks. The judges, we have 3 incredible sharks and a guppy up here, but thank you very much for what you've done. Stan, fantastic job. Thank you very much.
It's said he wishes to store his treasures in heaven.